Okay, the first key takeaway here, so is this guy here. So if I render GL fragment coordinates, so you can see, like, basically what I'm doing now here is I'm rendering half of the screen. So the whole screen is 80 pixels. So I'm saying if GL frag coordinate of x is less than 400, render this, else render this. Okay, all right, yes. So I'm gonna do this again. So you can see what I'm doing here now. I'm really going here, and the other part here is whether that's the texture. So that's first thing to note here. Then the other thing you want to talk about is front facing. Okay, so why that one comes in is not so obvious. Is here. So this they are seeing here is a front face, because this guy is a front face. Let me just do something. Yeah, so anything that is front face, render the first texture. What in the first texture? Let's name this texture one, and this is what we have here, wall. So let's go. Let's see where we have wall. So these are our walls, right? These are walls, and these walls, they are front facing. So every other thing that is back facing renders another thing. So let me change this color. I'm going to remove this, so we don't need to see this for now. And just gonna do this and hide this one. Okay, so if it is front facing, render the first texture. If it is or else render the front texture. I'm gonna hide this guy too. So you have just two textures, and here I'm gonna hide this. I'm not binding anything. I'm not bringing in this guy, and just going to select texture one. Coming. So this is texture. This texture one, which is a brick. This texture two. So any part you see that has texture two, which is like here. Okay, here. These are not front faced. Okay, that's basically what it means. That means it is back facing. The only part that has this front facing is this. This is separate texture entirely. So that's basically it. I think that's just covers it. Okay, probably one more thing they just need to talk about is uh, interface block, right? The interface block are basically let me go back. Should start from here. They are basically a way of grouping your variables in your shader. Think of it like struct. Struct gives you ability to group your variables, so to say, for organization purpose. So you have so the syntax is out. So this one is one going to the fragment shader. Then whatever the name is, then the value variable. So here, one key thing to notice, you can only change this variable when it's on out. Okay, so like here we can put the value of vs out texture coordinated vs out some vec, which is this guy here. The next thing wey you call it here is keep it as in, but you still keep this name. So this name is like the identifier name, like when you have street name. So this name still stays, but this in change and this instance name can change. That is fragment shader input. So one thing to take away here is you can't change the value here. It's only is read only. Okay, so we can just read this and you can see I read it here. I just have commented it out. So basically that's just one thing. Another thing that I didn't show here is uniform uh uniform block variable. Yeah, uniform block layout. Uniform block layout is similar to VSL. So just do call it here layout std 140 if I'm not right. Then you do uniform, then whatever name you want to call it, uh uh vari variable block, for instance. So this one is just you declare it similarly the way you do here in the uh, in the interface block, that you have like bunch of layout. You have bunch of varying, uh, but this time around they are uniforms. Okay, so you have say multi-fish for uh, math one, floats, math floats here, say color intensity. You can have an array, say array of vector, say colors, for instance, and you have to specify the number of arrays here, say 4, and so on and so forth. So these are the advantage of using this layout is that you can have multiple calls. You can reuse these guys in different shaders. So it's not very evident now, but in the future I believe I'll get to use this kind of stuff that helps, simplify the process of having to copy shader. So in this kind of thing now, you can just create one vertex shader that has this, that is applicable to all as many shaders, as many objects as possible. So I know this is so much talk, and I'll just keep it here.